Hello and welcome to part 2 of our introduction to LSL with Brain Products. I'm Tracy Warbrick. I'm the project coordinator and scientific advisor for the Brain Products Academy, and I'll be moderating the webinar today. So I'm very pleased to bring you this webinar from the Brain Products Academy. Before I introduce today's topic and our speaker, Dr. Alex Kreilinger, who you can also see on screen right now, I would just like to go through a little bit of information about GoToWebinar in case you weren't already attending the part 1 of our series, which was last week. Just so you know that part 1 is available on our webinar channel, so please do listen to that if you haven't already. And also this webinar will be available on our webinar channel a couple of days after the session. So please do feel free to listen to these again if you would like to. So if you haven't already used GoToWebinar, you should see the control panel at the side here. And what you should also see is that you're all in muted mode, so you're in listen only mode. And that's to protect your own privacy, so we can't listen to what you're doing in your lab at the moment, but mostly for the comfort of our speakers, so they're not interrupted. If anybody's having audio trouble, hopefully they can read this and see that you can change your audio output device and also do a sound check if you need to. And note that we do only offer computer audio and not audio via video call at the moment. We would like it if you ask questions during the webinar. We have a question pane in the control panel as well. And if you address your questions to staff, we can collect those and ask them to Alex at the end of the webinar. If something is really important to what Alex is saying, we can also interrupt and ask him at the time. So please do address your questions to us in the question panel. You will notice that there's a handout section. Don't worry that that's empty at the moment. We don't have a handout for this webinar, but we do have a really excellent blog post that Alex has written, and I will put the link to that in the chat once I've handed over to Alex a little bit later. Okay, so let's go back to my title slide, which introduces the topic today. So what we're doing is part 2 of our introduction to LSL, and what Alex will be covering is the hardware triggers versus LSL markers, and also looking at stimulus presentation software solutions for brain products and LSL. Now, Dr. Alex Kreilinger is your presenter today. He's our technical PM or product manager, and he's been at Brain Products since 2018. He's interested in assistive technology in general, but particularly in brain-computer interfaces, and he's worked closely with those with spinal cord injuries who can be assisted by BCIs and neuroprostheses. Alex has an MSc in electrical engineering with a focus on biomedical engineering and a PhD in computer sciences from Graz University of Technology in Austria. Prior to joining Brain Products, Alex has worked as a researcher at the Institute of Neural Engineering at the Graz University of Technology, and also worked as at the Artificial Vision Center in the Medical University of Graz, also in Austria. So as you can see, Alex has a lot of experience and knowledge to bring to this webinar, and I'm also looking forward to listening to what Alex has to say today. So on that note, I will hand over to Alex. I will just hand over presenter rights, and then Alex can take over, and I will talk to you again at the end for the question and answer. So over to you, Alex.
Thank you very much, Tracy, for this very nice introduction, and welcome everybody to the second part. So as Tracy already said, there is no handout, but rather I will go make this presentation based on this blog post that has just been released yesterday. And I will also not use regular slides because I want to go through a lot of examples and basically follow the narrative of this blog post. So let's just start what this blog post aims to do. So this aims to provide a hub for ideas, instructions, examples, analysis scripts, so you can run your own experiments with LSL and Brain Products equipment. So what I want to do is I want to base everything on a single paradigm. So this should be kept the same for all of these tools. So we can record those with our hardware and at the same time using LSL markers. And you should be able to record data and analyze this with different tools as well. But the one thing all of those have in common is the paradigm. So this will be a very simple one. We only want to make a flashing image of a square that goes bright and dark in 500 millisecond steps. And in order to compare timing in your recordings, we want to do 3 events that should happen simultaneously. So we want to compare when does the actual screen flash, and at the same time we want to send a hardware trigger to the Brain Products trigger box, and also at the same time we want to send an LSL marker. So in the end we should have 3 events that ideally should happen at the same time, and so a little spoiler alert, they don't, but I will show you how to analyze this and look at potential mistakes or point out simple things that you should consider. And those are quite different over these different stimulus presentation tools I want to show, but I will go through these one by one. So first, to start with, what will you need to record LSL and Brain Products equipment? So first you need to decide for an amplifier, and I have 2 here that I want to show you. One is our stationary amplifier, the ActiChamp. Here we already have an auxiliary inputs and also a connector for our trigger box, where you can connect an 8-bit trigger line directly. That said, of course, we will also need the trigger box itself. That's here. We can connect to this via USB and send hardware triggers that are then connected directly to the amplifier. And also, I have a mobile amplifier here, our live amp. The live amp itself has only a single trigger input line where you can send a single bit as a trigger, but if you want, you can of course also expand this with our sensor and trigger extension. So with this you have additional aux inputs and also the same 8-bit trigger input. So why would you need this? Because if you want to measure these 3 events I told you before, you will want to connect a photo signal, a photo sensor. So that would be this photo sensor here, and you can attach it to the screen and measure exactly when the square goes on and off. And so I will show in my demonstrations, I will use the live amp. So I will connect the photo sensor here, and I will frequently use the photo sensor to show you the photo signal. I also will connect the trigger box to the sensor and trigger extension, and then I will connect it to the live amp. And so once you have decided for the amplifier, you can go to our GitHub page, and David already explained this. We have a collection of LSL connectors for all our current amplifiers, for the ActiChamp, for the live amp, for the brain amp, and even for older amplifiers, you can still use them with recorder using the remote data access. So simply go to the corresponding live amp, go to the release tab and download the latest version, where you can, so here you can find an installer. And if you install this, this looks like that here. You can specify a number of channels. So if you only use the photo signal, I can put 0 here, but put 1 auxiliary channel. I will name this one PS for photo signal. This will become relevant for later analysis, so please keep that in mind. And you can do some more settings like the sampling rate, but the most important settings for LSL markers or hardware triggers in this case would be to have this one here activated. So this is the type how triggers are, how hardware triggers are sent via the LSL stream. And it's better to use EEG channels, because then the triggers are sent as an additional channel and not just as an irregular stream where the jitter is higher. You can activate both, but I would suggest you only activate this. Otherwise, you have additional streams in a network that you don't really need. And then you would simply scan for a device and link this. That said, I'm not going to use the same computer I use for showing you this in GoToWebinar. Instead, I have already set up a local network. Also, as David has mentioned, having a proper network is one of the most important things to consider. And if you have a cabled network, so I'm using a network switch in between my two computers, that's basically the most reliable, and you don't have to worry about any outages of your Wi-Fi. So what I have already done, I have connected this to the sensor and trigger extension, and now I will start the LSL LiveM connector on my second computer. And as soon as I do this, I should be able to see the stream in the network. So that brings me also to the next step, visualization of data. And you can do this by downloading our LSL viewer. It's free. It's freely available on our website. You can download and start it, and it can display one regular stream and multiple irregular streams. So what I mean here is one EEG data stream, basically. And if you connect to this one, you can already see that there is a channel that's called PS, and this is basically showing you the photosensor signal. And you can already see that this signal, if you put it on a screen, is very well capable of acting as a trigger signal. So even though we are using the analog signal, you can also see other signals here. Let's just go for all of the signals we're seeing. So for example, here we see the accelerometer signals. I have to zoom in a little bit more so you can see it when I touch the LiveAmp. And then you can see two trigger channels. That's what you get when you activate EEG channel. And the LiveAmp has two, because there is one channel for the device triggering with the single input, with a single 1-bit input. And there is another line for the sensor and trigger extension. So let's just look at only these two. Now, of course, I'm not sending any triggers, but I will connect my trigger box and simply send some triggers to it. And as you can see, I'm doing this now. I'm just sending a cycle of triggers. Of course, I should zoom in a little bit more. You can see the triggers appearing on the sensor and trigger extension channel. As you can see, there are no triggers at the device triggering, but this is also something I want to show you. Let's say you don't have a sensor and trigger extension, or you don't want to use it. You can still use simply the LiveAmp alone. If you, for example, ask your local distributor for a special cable, I have one here that goes from the trigger box. It attaches only to the first bit line, and it goes directly in this 2.5 jack. I connect this to this single input line, and then I can also get triggers on this line here. So of course it's only 1 or 0, and what you can see here is that the channel is always -1, and only if a trigger gets in, it quickly jumps to 1 and then back to 0. So it's positive down in this case. Yeah, but that gives you an option to try this without using the sensor and trigger extension. So that is about displaying the signals. But of course, you also want to record the signals. And for that, you would need the lab recorder. And you can download this. Don't worry if you miss any links. For example, everything should be in the blog post. So you will find a link to this download as well. And if you do that, you simply see all of the streams available in the network. And now it's just the LiveAmp. I can check it and record it to an XTF file, and then analyze this later. So we will come back to this later. But now let's go through all of the different software presentation tools. So as you can see here, we have instructions and some tips for ePrime, presentation, PsychoPy, and PsychToolbox, but there will also be some additional information at the end. Since it's the first one here, let's also start here in ePrime. I will show you here. So this example you can also download, and it shows you a very basic example how to use LSL markers and hardware triggers. So it's sometimes you want to use LSL markers instead of hardware triggers. I mean, hardware triggers always have the advantage that they are exactly recorded with your EEG. So it's the most precise way to get triggers into your data. But sometimes you simply do not want to connect any cables, or let's say you have a mobile scenario, or you want to combine the EEG with other LSL streams anyway. Therefore, it's simply not feasible to go for hardware triggers. And that's why you may want to switch between hardware triggers and LSL markers. Or exactly for this purpose here, I want to record them at the same time to compare the timing and make sure that everything works as expected. So it's important that you can easily switch between these options. And I want to show you that exactly. So in order to use LSL for ePrime, you first have to download a little package that's available on PST. You need to install this. It requires a few manual steps, but everything is very well explained on the README file. So I will not go through that. I just want to show some steps you need to make. So you need to make sure that in this experiment settings, you have the package called LSL activated. And also important, you need to have the LSL DLL file in the same folder as your experiment. Of course, is the trigger box. So you need to have the trigger box activated. So there is this class serial that you have to check, and here it's called trigger box. It doesn't have to be called trigger box, but we later refer to this name. The only important part here is that you have the correct COM port selected. So once you have those two things activated, you should be able to use both. And there are some things you need to do first. There is this additional code that has to go into the user script, but don't worry, this is already in the example. I have also simplified this a little bit, as I do not want to use a complete XML wrapper for sending markers. So in this case, I really just want to send a single number. And I also changed the way that ePrime made you connect to an LSL stream, because it should also be possible to start LSL without connecting to it. That said, a good practice would still be to add a break in the beginning, where you have time to connect your lab recorder, for example, to start the recording, and then at the end provide some time to close the recording. So you don't accidentally delete the LSL stream before it's properly saved to the XDF. So that might cause a broken XDF file. And then there's still one simple init block where you define the LSL stream and start it. And how to send these actual markers and triggers, that's done here in this loop. And it's happening in these objects. So we have two image objects that show a square, a bright square and a dark square on top of the screen. And you can set some options here. There are two important tabs. One is the duration that tells you how long this lasts. So here it's for 500 milliseconds. And we also provide some time for the follow-up event to be ready when it's time. And another important part is the task events, because we use task events to send LSL markers and hardware triggers simultaneously. So the first one is, so this happens exactly at the onset time of the square on object without any delay, and immediately the action LSL send marker is called and sends a marker, so which is a variable basically, but in this case it's always a 1, to the LSL stream. And this action was the function defined in the user script. The second event we have here is the write byte action that refers to the trigger box and sends an integer that it gets via the marker to the trigger box. So you have these two events that ideally happen at the same time. So that's it. I would like to demonstrate this, but I cannot do this on the same computer because ePrime really takes over your display, and it's not possible to show this in GoToWebinar. Instead, I have it prepared on my second computer as well. I just need to switch the trigger box over to my second computer. Otherwise, I cannot send triggers, of course. But when I do, I should be able to start. And once it's starting, it gives me a break, so I have enough time to connect to the LSL marker stream. So let's see if it's already available in the network. So I can again check what streams we have, and here you can see a stream called ePrime with an arbitrary number, and my LiveAmp stream, of course, is still running because I never closed it, so I just keep running in the background. And now I haven't started yet because the break is still on, but if I go on, you can immediately see I get the markers from the sensor and trigger extension, but also from the device trigger, and because I still have this 2.5 jack cable connected. And also what's new is you can see the LSL markers appearing on the bottom, and this is the irregular stream. So they only happen when they actually do happen. There are no -1 all the time when there is no marker. So yeah, and you should see that those are at the same time. But if you look very closely, you will also notice that they are in fact not exactly happening at the same time. And it seems like the LSL markers are appearing earlier. But let's get back to this later. At first, I still want to show you what happens when you do use the photosensor. So let's go to the photosensor. It's just lying around here, but when I take it and put it on the square, which is on the top left corner, you will see now, okay, we have brightness going up and down in these intervals of 500 milliseconds. So again, that should also happen at the same time as the LSL markers and the hardware triggers. And that's what we can later analyze in the recorded XDF file, if we recorded one. So that's for ePrime. The next part is presentation. Let's go there. And so to quit an experiment in ePrime, you can always use Ctrl-Alt-Shift, but that's not really nice. It will not delete the LSL stream. So this is not recommended just for programming. So, but as you can see, no, you cannot see because now I closed ePrime. So you have to close ePrime for the stream to go away. You can see here, now it's gone. In the meantime, I'm starting presentation. And I will be greeted by a warning. As you can see here, it loads the previously loaded experiment, and in there I specified a COM3 port, and this is no longer here because remember I connected the trigger box to the other computer, but so I do not want to repeat all the settings, so I just click OK. I close presentation again, and then in the meantime I connect my trigger box back to this computer. And I start presentation again. So once it's back, so I do not get this warning anymore. And in the scenario I'm loading is a very simple example. You of course can download it. It only has the scenario and two pictures for the square on and off. But also it has the settings in there, and relevant for this is the first part in general, where you can simply activate LSL. So presentation already has LSL pretty well included from scratch, so you don't need to do anything. You only have to check this box here and then do some settings if you want. So one is really a very nice setting. when you activate this one here, you immediately create the stream. So you can already verify if it's visible in the network. So let's just do that. You can see immediately, without starting any experiment, it's already there. So you could already connect to this and start recording, so you are sure not to miss anything. It's also good to check your network connection to make sure everything works as expected. Some further things you can do here: you can run some tests, and you can set how the string marker or how LSL markers events should be sent. In this case, to make it comparable, I activate it to send event codes only. And yeah, so now every time an event happens, there will also be an LSL marker sent. The second part, for the trigger box, you have to set here in the output ports, and you can see it's already taking the setting from before. The important part here is setting the correct COM port and activating emulate parallel. You need to have some values in here, but the nature of the values are not really important, because it's not the real serial interface. One thing I should mention here is that for all of the other examples, I tried to set the trigger lines to 1 and then back to 0. But here I had to provide a pulse width, and in this case, it simply went for the 5 milliseconds. So it was not like a long pulse of 500 milliseconds all the time, but in this case, it's just a short pulse. It doesn't really matter, because for the analysis, we only use values of 1 anyway. Because it also changes the shape of the photo signal. So it doesn't matter for this, but just to let you know that there is a difference here. So for the code itself, very few lines of codes. And the important part here is, if you use it like this and you have the LSL functionality activated, you send both hardware trigger and LSL markers. But if you do not want to use hardware triggers, you have to comment this line here. So in that case, you will still write LSL markers. And of course, if you only want to use hardware triggers, just uncheck the box with the LSL feature. What happens here is we provide a pulse width, a different one, but still it's a pulse width. We load the images, and then we go through the trials. A trial is supposed to last for 1 second, and there's always a square on picture and a square off picture. And for the square on picture, we send the port code 1, and for the other one 0. So we get 1 as a marker and trigger at the same time. And again, the square should be shown simultaneously. So what you will see that in the summary after running this, you will notice that it's not exactly 500 milliseconds, but there is some additional time sometimes. But for this kind of experiment, that didn't really matter, because we were only focusing on the synchronization accuracy and not the timing. So for example, if we want to make sure that this is really 10 repetitions are exactly 10 seconds, then this is not the correct way to do this, but there are many different ways to do this. So you can read up on this elsewhere. At this point, I should also mention, I've already put this in a disclaimer, the examples shown here are not supposed to be best practice examples, but rather than they are rather aimed to show you simple implementations. And as a nice side effect, you can also sometimes see that things are not working ideally if you're not doing, considering everything. And this is just a nice way to show up these potential issues. Again, I won't run presentation on the same computer, but rather start this on the second computer. Again, just have to switch to trigger box. I was a little bit too late. I have to restart. But I mean, it's basically the same thing you can expect. I start this, and there is also a break. It gives me time to connect, and I can already see I still have the live stream here, and there's this stream coming from the second computer called presentation. I can already connect to it, and as soon as I start, you can again see the LSL markers coming in, and of course also the triggers. There are only ones in this case. And what I meant with pulse width, you can see this when you zoom in a little bit more. You can see here, instead of going 1 and 0, it's just a very short pulse that you can see here. But for analysis, it doesn't really matter. All of these scripts should work no matter how you did this. So I can easily close this with pressing escape, and I'm gonna close. And then the next part is PsychoPy. I don't want to go into too much detail on PsychoPy because yes.
Alex, could I just interrupt you? I think we have a question that's very relevant to what you just said, and it might be easier to answer now than move on. So why are there 2 pulses instead of 1 in the example that you just showed?
That's what I meant with the pulse width. You can see the effect of this rather short pulse width I set in presentation. So for the other examples, I set the lines of the trigger to 1, and then I waited for the square off to set it back to 0. So you had a very long pulse of 500 milliseconds, but in presentation, I defined the pulse width to 10 milliseconds. So instead of going up to 1 and then going back to 0, 500 milliseconds later, it goes back to 0 almost immediately, and that's what you saw. And since usually it's a -1 in the channel, you can see it as 2 values, so a 1 and a 0.
Okay, great, thank you. Hopefully, I think that will have answered the question for our participant. Okay. Sorry to interrupt. Carry on.
No problem. No problem. So for PsychoPy, I don't want to go into too much detail because there is one press release article already dealing with how to verify the timing, and this one is only based on PsychoPy. So the new blog post here basically builds on that. I still want to go quickly through this. So because it's easy to demonstrate, because PsychoPy is based on Python, so it's nice code that you can easily understand. And I just want to mention you should ideally download the standalone version because it's more likely to work without interfering with any other potential Python installations. And then just make sure you have these things available like PyLSL, and then you are ready to go. Basically, you need to simply be aware of how LSL and hardware triggers are generated, and those are basically happening in these commands defined in one single function. And whenever this function is called, we send a hardware trigger and push the same value to an LSL marker stream. So in order to do that, we first have to define the LSL information. So we name the LSL marker stream, and then we open it, and then we go through this for loop that's based on frames. So the timing here is based on the frames, so the screen refresh cycles. And since I'm using a 60 Hertz monitor, I'm using 30 frames. That means it lasts for half a second. So half a second, I will show the square on, and half another second, I will show it off. And only at the beginning, when it changes, we'll send this function that sends at the same time hardware triggers and LSL markers. And this call on flip command is supposed to synchronize this with the actual flip of the display. So at least that's what we want to do. And one more thing I should mention is the squares are drawn in, instead of loading images, just to show another example. And I can actually run this, although it's not very good practice because I'm not using full screen, as you can see here, by using a small resolution and putting full screen to false. But I can demonstrate it. So let me just load this. I should also mention this is written in PsychoPy coder environment, which means you get it done with a very small number of code. You could also use the PsychoPy builder interface, which is a graphical user interface, but this would result in a lot more code. That said, you can still give it a try if you want. So now I have this running, and well, just to show you once how the paradigm actually looks. Of course, this usually would be full screen. Yeah, I think we don't need to go through the LSL view again. You would also, of course, also see LSL markers and hardware triggers again. So let's just quit this with escape, and let me close PsychoPy. So there's one more on the list, PsychToolbox. This is based on MATLAB, and let me quickly load MATLAB in the background. I don't also want to go into too much detail here. It's very similar. I would say that the MATLAB script looks very close, similar to the one in Python. Just to prepare for this, you can download it from PsychToolbox and follow the instructions. And also, you should install the MATLAB interface for liblsl, so you can actually use LSL in MATLAB. And here is the example, of course, also provided as a download. So very similar, as I said, we start the LSL creation and the connection to the serial port. And then this is also based on screen refresh rate. So a similar for loop runs based on the time screen refresh cycle takes. And then whenever we change the rectangle or the square, we send at the same time an LSL marker, in this case a 1, and write to the serial port also a 1, or if it's dark square, a 0. And at the end, we simply delete the LSL marker stream. But yeah, basically, it's very similar to PsychoPy. And of course, what I didn't mention is, again, if you want to deactivate LSL or the hardware trigger functionality, simply comment the lines that are not necessary. So simply comment this here and here if you do not want to use LSL markers, or the other way around if you only want to use LSL markers. Yeah, so much for MATLAB. Now you will notice there is one more section here, and while this is no stimulus presentation software tool, it's another nice way to test LSL markers and hardware triggers. So this you can do with the TriggerBox test.io, and this is a little tool that you have to download anyway if you want to use the TriggerBox as a serial interface, because all of the other programs require this as well. I just didn't mention it before. So you can download this from our website. This basically installs the drivers to get access to the TriggerBox, and it comes with this GUI that you can use. And it looks like this. And the only difference to the previous version is that you can now also activate LSL marker output. If you do not check this box, there is no difference to the previous version. But if you connect it, you will immediately create a stream in the network. So let's just see. You can see I just activated it and it's already visible in the network. If I deactivate it, it's gone again. And this is just to test basically the latency between LSL markers and the hardware triggers. Because now I should explain this a little bit. LSL markers, they do appear immediately. So whenever you send an LSL marker, they are put on the LSL stream, and there is no need to wait for anything. So they are available immediately. If you compare this, or if you combine this with a hardware stream, the hardware stream may have a little bit of a delay. So because the hardware data, so the signals that are recorded with an amplifier are not available immediately. And this depends on a lot of factors. For example, the type of the amplifier. Let's say you have the live amp. This is connected to the computer via Bluetooth. So the Bluetooth connection takes a little bit in the range of 10-15 milliseconds. Compared to that, when you use the ActiJamp that is connected via USB cable, there's no such delay. So at least the delay is much smaller. So that's one thing you might want to be aware of. And it's not just the type of amplifier, it's also the sampling rate or the number of channels. So this is something you can verify with this. And you can, of course, also verify this with the stimulus presentation software tools. But in addition, with those, you can also verify when does the screen actually update. Or if you use a different paradigm that's not based on a visual stimulus, you can also record acoustic stimuli, for example, and see how long does it actually take for the program to start these stimuli. And that's what all of these examples should provide. And the analysis scripts I'm getting at now should show you a way how to analyze this. So let's get back to this blog post and open one of those analysis scripts. So I have uploaded one for MATLAB and one for MNE Python. And you only need to fulfill some requirements to make this possible. So you need to have at least one hardware trigger channel, and you need to have an LSL marker stream, because that's the minimum you want to compare. You want to compare the timestamps of the markers coming in via LSL to the hardware trigger timestamps. So of course, that means also you need to have the same number of triggers. So if anything went wrong, you might have to manually correct for that. In addition, if you recorded a channel named PS, we will assume, at least that's what I do in these scripts, that it's the photo signal channel, then this will also be analyzed. And this, of course, is an analog signal. So we will have to put a threshold and try to get the onset of the photo signals to provide photo triggers. And then you also have timestamps for the onset of the photo signals. And now you have 3 events that you can compare. And this happens in these scripts. There are some settings, for example, default values are inserted. So please note here that you will have to install the MATLAB XDF importer. The handle jitter removal, this is usually useful because it takes care of potential jitter. But if you want to make sure if anything is broken, please always give it a try without setting this to true. So it might give you a better idea if your data looks to be broken in some way. But what we do here is basically we go through the data, we look for EEG and LSL marker streams, we look for the photo signal channel, and then we compare the timestamps and make a picture. And when I run this, you can see some suggestions here. These are all files that are provided in a download file. Also in this file, there will be an explanation how these files were recorded to give you a better idea what makes a difference. So just look at this one here. This one was recorded with E prime with a live amp. And what's very nice about this is if you look, so we plot over the time, that is the number of events, the latencies between the 3 events, so the timestamps. So what you can see here is that the latency between hardware triggers and photosensor signals, or triggers based on the photo signals, are happening exactly at the same time. This just means that E prime really takes care that the stimulus you see on the screen happens exactly at the same time as the hardware trigger. And the jitter or the deviations here are single sampling time. So we use 500 Hertz, so these are 2 milliseconds, either before or after. What you can also see is that compared to LSL, so either with the hardware trigger or with the photosensor triggers, LSL is always appearing around 15 milliseconds earlier. And that's what I said. So the LSL markers appear immediately, whereas the signals coming from the amplifier need a little while extra. And that's what you can see here. So there will be a few examples, but let's also switch over to the script provided in MNE Python. So for that, I will use an environment that I created where I have everything already installed. So I call the editor, so I'm using Spider, which I think is pretty nice. And in there, I already have everything installed. So most important thing I would say is make sure you have MNELab version 0.8 installed. And all of the other packages, it would complain anyway if you don't have them installed. But just to quickly show you how this looks like in MNE Python, it looks quite similar, but let's just go for one other stimulus presentation software, in this case PsychoPy. Let's see what happens here. So if I have everything installed correctly, and if I have the file in the correct path, in this case in the same folder, I should just be able to press on play, and after a while I will get some statistics and also a plot that looks quite similar. It's a bit different to MATLAB, but it does the same results. The only thing a little bit different is the creating of the thresholds for the photosensor signal. But getting to the point, what I want to show you here is what you would expect is that the hardware and the photosensor signal happen at the same time. But in this case, the photosensor actually happens more than 17 milliseconds later. And this means there has to be an additional screen refresh cycle I was not expecting. So this can happen easily. If you, for example, make some settings on your graphics card, for example, you set the background resolution on Windows to a value other than 100%, or you have some triple buffering activated, you can easily introduce additional screen refresh cycles. And of course, if you want to use these LSL markers for timestamps to trigger ERPs, that can, of course, make a difference. So that is something you should be aware of. And if you add this to the delay of the hardware signal, you end up here, compared LSL markers to photosensor signals, you even arrive at 30 milliseconds. So I would say this is not negligible. Yeah, well, of course, you can find a lot of examples also in the blog post. I copied a lot of figures here. There are also explanations on how they were recorded. So as you can see, for example, these two are both recorded in presentation. One was done with LiveAmp, and the other one was done with ActiveGen Plus with similar settings. But here you can see that the latency for ActiveGen Plus is much lower at around 3 milliseconds. And here we are at the 13 milliseconds with one single channel, 1000 Hertz. So I would always recommend to test this exactly the same way you want to use your experiments. Use the same program, use the same sampling rate, the same number of channels, and of course the same stimulus presentation software tool. So there are some other results. This one is a result from the TriggerBox test.io. Of course, it only provides hardware and LSL markers. You can see the jitter is very small, but it looks like a sawtooth effect. This is just an effect because the delay is very stable, and that just looks like this. So in fact, it's pretty stable, but still it's an unrealistic outcome, and I would not use this for evaluating my stimulus presentation software. Another bad example here, I'm not saying it cannot be better, but this is recorded in PsychToolbox. Here we have even a second screen refresh cycle. So 2 times 16.7 milliseconds for 60 Hertz. So that makes it even worse for using this for ERPs. Yeah, so just one more thing. If you don't want to use the script, you can of course also go a different way. Looking at the XDF files, you could also use MNELab. MNELab is a very nice graphical user interface for loading XDF files, and I can, let's just open one here. You can see immediately what kind of streams there are available. So there was a data stream and an LSL marker stream. And when I load this, I also get this nice meta information. And then if I have installed PyBV, I can export the data to the Brain Vision data format. So I already did that beforehand, and just want to show you that you can then easily load this file in our own analyzer software. And just to quickly show you another way to do this. So here is the file I exported from MNELab. So it shows you the photo signal, and as you see, it was recorded with a live amp, as there are 2 marker channels, but we only need the sensor and trigger extension one. And here you can see, well, very nice, the photo signal and also the triggers coming in, and here the LSL markers. So this is just a visual effect that you don't see all of them, but you can see the LSL markers. And for example, you could do a segmentation based on the software, the LSL software markers, and then you can see that as ePrime does this very well, the onset of the photo signal is really happening exactly at the same time as the hardware trigger coming in. So this also is very stable when I go through all of the events. And of course, you could also do some more visualization. For example, there is a solution you can download called Right Markers. If you do that, you export the delays based on a reference. So here you see LSL marker at time 0, and then 16 milliseconds later would be the hardware and the photo signal. But for example, using a macro, you can also visualize this, and this is basically comparing hardware triggers and LSL markers. And if you move the mouse pointer here, it tells you it's around 14, 16 milliseconds. And this is basically this one here. So it gives you the same result. So you're a little bit more flexible. You can play around. Of course, there are also ways to make this more visually appealing, but just to get you some ideas on what you can do. So yeah, this was basically it. I of course put also my email address in a link somewhere, so I would be happy if you try out some of these ideas, and if there are any questions even after this webinar, please don't hesitate to write us an email. We are also happy to get ideas or reports on what you did, so we are always happy to get feedback. But for now, I'm looking forward to get some immediate questions. And yeah, thank you.
Yep, thanks, Alex. That was really great. We do have some questions. I'm going to start with the ones most recent because they're related to what you just did.
Okay.
So the macro that you just used in Analyzer, is that something that's already implemented, or is it a custom macro that you made yourself?
This is a custom macro, I'm afraid. So I just wanted to show you a few options, but the solution you can download from the solutions page. I think it's even here. Yeah, it's on the Analyzer solutions. It's among them, and it's called Right Markers.
Okay, great, thank you. There's a thank you for the amazing presentation, which I have to agree with. And also, will you send us your codes for evaluation with our own setup, or is it available in the web? Am I right in assuming that that's what's available via the blog post?
Yes, basically everything you saw is available. So you might have to look a little bit because it's a long post. But if you go here to the recording and analysis part, yeah, I have to look myself. Here you have the two scripts. One is for MATLAB and one is for Python. But yeah, so they should be, so at least they work for all of the software present tools I showed, given you fulfill the requirements. But I think it's, I always try to minimize the code necessary, so it should be easy to adapt to your maybe slightly different recordings.
Great, sounds good. You've provided a lot of tools for the users there, which is great. Okay, one question about the delay between the photosensor and the hardware triggers. So would the delay also be impacted by the stimulation itself? So for example, if it was larger pictures that take longer to load, and would it be better to have the photosensor sensing the actual stimulus rather than a white rectangle?
I think it can depend on how you create this, but I think it also depends on the presentation tool. So for ePrime, for example, you can allocate some pre-release time, so you can be pretty sure that the image is already loaded in the background. But let's say if you do some complex drawing that is not preloaded, it might actually affect this. But of course, yes, I would, as I said, test what you want to do and not a dummy square. So use it on your actual presentation setup. For example, you might just use a bright piece on your image to put the photosensor there, just a suggestion. So yeah.
Okay, sounds good. Okay. Hopefully you can answer this one. Are you aware of any best practices for syncing audio playback and LSL markers?
Well, I think that also depends a lot on the tool you're using. So I've tested this myself out of curiosity, also in PsychoPy, and that makes a huge difference on the settings you make. So for example, what kind of tool you use for playback, how you preload this into the buffer, so you can get from a few milliseconds to hundreds of milliseconds easily. So that's why I said, please don't take this for photo signals only, but I think the same principle should also apply on auditory signals. And for example, using the stim track, that should also be a nice tool we have that can record this properly.
Okay, sounds good. Okay, we had a couple of thank yous as well, so I guess you're answering the questions exactly as expected, so that's great. Just for all of the attendees, we're coming up to the end of the time, so if you have any questions, please do ask them. I still have a couple to go, but if you have any burning questions, please write them now so we don't miss them. Okay, so I have a question here that relates to using Wi-Fi instead of the wired connection.
Yeah.
So yes, it's clear that it could be unstable, but does it add any significant delay or jitter that you're aware of, just in case there are people who really want to use a wireless setup?
So I'm not aware of that. It's just that you are on a safe side using a cabled network.
Yeah.
Yeah, okay. So that's at least my experience, and I think David also said something to that direction.
Okay.
Yeah.
Okay, then I think we would just finish with one final question, and that you have shown really nicely all of the ways to test this. But if somebody doesn't have their hardware set up to be able to compare these differences between the hardware and the LSL, is it okay to just go ahead with the LSL triggers, or would you always recommend trying to test somehow?
Well, as you could see, it depends a lot on the hardware settings. So it sure would be nice to know the latency for your exact setup. And maybe there is a way to use this without requiring a trigger box or without using a sensor and trigger extension. For example, what I said, using a photo signal directly as an input into the live amp. Maybe there is a way around, or maybe you can just do it once to make sure what you can expect. Although I would always recommend to repeat these measures in between, because just a simple update may again make a difference. And I have observed this personally. So yeah, but of course, if you don't have anything available, yeah, you have to make do with what you can.
Okay, good. That's great advice. Okay, it looks like that's all of the questions that we have, which is pretty much perfect timing. So that's great for today. We're just up to the hour. So I would just like to thank all of the participants for attending the webinar. It's great that you're here today and we're asking questions. It's always nice when you're interactive with us. And I would like to thank Alex for the excellent presentation and for answering your questions so well. And just to remind you that this webinar and also part 1 will be available on our webinar channel for free, so you can watch them again if you want to. So yeah, I guess that's all from us. So I'd just like to say goodbye and enjoy your evening or the rest of the day, wherever you're joining us from. Bye.
Thank you, bye.